Good day. We are Group 6 from BS Civil Engineering second year. Today, I, Kim Vincent Emberano, the main programmer of the team, together with Asli Ann Castillo, John Joseph Manalo, Kian Charles Maranan, and Adrian Victor Martin. In this video, we will present our final project in CPE 402, Computer Programming 2, entitled Quakesense, Structural Safety and Earthquake Hazard Assessment Tool. Quakesense is designed for students, civil engineers, researchers, and potential investors, allowing users to input site and earthquake data to assess potential ground shaking and overall structural vulnerability. It includes computations for peak ground acceleration, structural risk evaluation, retrofitting recommendations, and exceedance probability, aiming to support informed decision-making and enhance seismic preparedness. Built using libraries such as NumPy, Pandas, Matplotlib, Datetime, OS, and SYS. The program features a Welcome tab, Home tab, and Main menu where users can visualize data, perform calculations, and save results, all working together to create a simple, efficient, and user-friendly earthquake assessment tool.
Hi everyone, I am Kian. To start explaining our program, we use the setup project function. This section prepares everything the tool needs by collecting basic site information. The user enters the project name, the location, the soil type, the building type, the foundation type, and the number of stories. The program checks these inputs to prevent errors and to make sure the data is complete. One of the most important features of this section is its ability to record earthquake events. Here, the user can input key details such as the date of the earthquake, the magnitude, the depth, the distance of the epicenter from the site, the type of fault, and the intensity. The user can add multiple earthquakes and all entries are stored inside the Pandas data frame. Meanwhile, the general site information is saved in the project data dictionary. This setup stage is very important because all other tools depend on the data collected here. Without proper inputs, the calculations will not work correctly. This includes the tools for structural risk and retrofitting. Those features require a computed PGA value, so they cannot be used unless the user has already run the PGA option first. This is why the setup and the PGA tool serve as the foundation for the entire program.
Hello, I'm Asli. After the user enters all required data, they can now open the visualization tool. This tool creates a scatter plot that shows earthquake magnitude against distance. The plot helps the user identify which earthquakes were strong and which ones happened near the project site. Visualizing the data makes it easier to understand hazard trends. We use the Matplotlib library to generate this graph. Furthermore, we have the PGA tool, which is one of the most important parts of our project. PGA stands for Peak Ground Acceleration, and it tells us how strong the ground shaking can be at the site. The tool uses the compute_PGA function. It considers the magnitude and distance of the earthquake, as well as the soil factor, the importance factor, and the amplification factor. Each soil type has its own multiplier. For example, soft soil will produce higher shaking values. After the program computes the PGA, it gives a hazard level. This can be low, medium, high, or very high. The tool can also generate a simple visual indicator to show the level of shaking in a clear way. This PGA value is very important because it is needed before the user can run the structural risk and retrofitting tools. Without a computed PGA, those features will not function.
Hi, I'm JJ. To continue, the program also includes a structural risk assessment tool. This tool uses the PGA value together with the building type, the foundation type, and the number of stories. Each material such as concrete, steel, or masonry has a factor that affects its performance during an earthquake. These values are used to compute the project's damage index. Higher PGA values or weaker building conditions lead to a higher damage result. The program then classifies the damage as no damage, slight, moderate, severe, or collapse. This makes the output easy to understand even for people who are not engineers. After this, the user can open the retrofitting tool. These tools give suggestions based on the damage index. If the damage is low, the structure is considered safe. If it is moderate, the program recommends minor reinforcements. And if the damage level is high, the program suggests significant retrofitting to improve the structure's stability. These two tools help the user understand how safe their building is and what steps they might need to take.
The last computational feature is the probability of exceedance tool. This function uses a Poisson formula to estimate the probability that a given level of shaking will be exceeded within a specified number of years. The result is shown as a percentage with a simple risk-taking. This helps the user understand the long-term earthquake risk of their project site. Lastly, after checking all the analysis results, the user can now open the Save Data option. The program can save the collected information as a CSV file or as an Excel file. If the user chooses Excel, the program uses OpenPixel to format the headers and adjust the column widths. If Excel cannot be saved or if the user chooses not to use it, then the data will automatically be saved as a CSV file instead. This ensures that the information is always stored in at least one format, and the user will not lose their data. Finally, everything is controlled by the main function, which manages the menu loop. It guides the user through each tool and allows them to go back or exit at any time. This concludes our presentation of the Quakesense Earthquake Hazard Assessment Tool. I hope we catch your ears and boost your mind in investing to our program. Again, we are Group 6, presenting Quakesense, Structural Safety and Earthquake Hazard Assessment Tool. Thank you for watching and thank you for listening.